This question is a conceptual question. It's 30.2. It's a transformer. So basically, we're going to have two coils. Let me draw them. So we've got two coils like that, and they're close to each other. So we've got two. They say they're in close proximity. And we're going to have like a bar, basically, like a little bar that connects the two, a metal bar. Okay. Usually it's a lot thicker than that, but I'm just showing that as an example. And they say basically it's going to induce an EMF in the second coil. And they say they can change the geometry of the two coils. But they ask, why does it only work with alternating current and not with direct current? Well, the answer for that turns out to be pretty simple. Okay. Because basically, this coil, in order to get some kind of an EMF out of it, that's going to be measurable. If this is our voltage meter, to get an EMF, that means that, like if this is a voltage meter, to get a non-zero number on it, if we're going to get a not zero number out of it, that means that that I have to have a change in the flux with respect to time that cannot be zero. Okay. And since the coil's not changing, the only thing that can be changing, A, is constant. So that means that the actual in the second coil can't be zero. Okay. So that's the only thing that can change, that has to change in order for us to have some kind of a reading on that meter. Well, the only way that can happen is if that field that's inside there comes from the field over here. So that means that this field cannot be zero. And the only way that can happen is if we have a current going in here that's not constant. The best way to ensure that is to have the alternating current. A direct current would give me a constant current. That means that I would have no change in my magnetic field at all. And I have no change in this magnetic field, which would mean I have no change in here. My flux would be constant. And then I'd have a reading here that would be zero.